Hi, today we're going to talk about how we can use square roots to help us with quadratics. To begin, let's review what a square root is. So looking at problem number 1, when we have the square root of 16, most people would say that equals 4, which is true because 4 times 4 does equal 16. But we have to keep in mind that there's another number that will also give us 16, negative 4 times negative 4, which gives us that 16 we were looking for. Therefore, the answer for the square root of 16 is 4, but also negative 4. Now, when we look at the square root of 40, we know that the square root of 40 will not give us a whole number, because there is no number times itself that will give it 40. So in this one, it will equal a positive and a negative, but it will equal a number that's about 6.4 or 6.32. Now, number 3, the square root of negative 64. There's an issue here because there's a negative sign within the square root. Therefore, the answer is not real numbers. There is an answer that will work. The square root of a negative number actually equals what we call an imaginary number. So technically, the square root of negative 64 would equal 8 imaginary number. Now, we're going to talk about absolute values. When we say x, absolute value equals 6, we can look at it as x equals a negative 6 or x equals a positive 6. But if we look at number 5, we have to say there's no solution. And the reason there's no solution is because of the negative 8. Now that we've used square roots, now let's talk about how it goes with quadratic equations. We're still using a x squared plus bx plus c. But when you're talking about solving through square roots to be able to find out the answers, you cannot have a b. The only way solving by square roots will work is if you have b equaling 0. Reason being is because of the middle of the trinomial. Not having a b allows us to have a binomial, which will make us able to square it. So let's look at the first problem with the quadratic. X squared equals 25. We're going to take the square root of both sides. Therefore, x would equal plus or minus 5, because 5 times 5 does give us 25. But negative 5 times a negative 5 also gives us that 25. Now, looking at number 2. We have an issue because the variable is not isolated. So the very first step here would be to add 12 to both sides. We now have 2x squared equaling 72. Still do not have our variable isolated, so we are going to divide both sides by 2. Now we have x squared isolated, and it would equal 36. Therefore, we can now take the square root of both sides and have our answer equal plus or minus 6. Now I want you to try these two problems on your own. Go ahead and pause the video and then start to look at the answers. Alright, hopefully you knew on number 12 to subtract 12 from both sides. When you did that though, we should have realized that we ended up with a negative 9. And the fact that you had a negative 9 makes it, when you take the square root, have an issue like we talked about in the warm-up. Therefore, in this problem, we have no real solution, based on the fact that the negative sign is inside the square root. Now, what's nice about number 4 is we have a negative attached to the 2. So when we divide by negative 2 from both sides, we're able to isolate the x squared, therefore making it a positive 50. We would then take the square root of both sides, making it x equals plus or minus the square root of 50, which equals approximately 7.07. One more example here. What happens when we have a 0? We would have x squared equaling 0. Well, can you take the square root of 0? Does 0 equal 0 times 0 give you 0? Would a quote-unquote negative 0 times a negative 0 also give you 0? Therefore, this does have a solution, and the answer is simply 0, because there technically is not a such thing as a negative 0. Now we're going to apply it to your guys' favorite thing, geometry. The area of a circle is 300 feet squared. Find the radius. Well, we have to remember that area of a circle is pi r squared. We now know that the area, based on this problem, is 300. So we can insert that for the area. Pi is a value, so it is able to be divisible by both sides, therefore giving us 300 divided by pi, equaling r squared. Now, just like the other ones, we've isolated the variable, we can take the square root of both sides. So technically, r equals plus or minus the square root of 300 divided by pi. The issue is, though, would you use a negative radius? Obviously not, so therefore in this situation, due to the context of the problem, you would not use the plus and the minus. You would just use the plus. And the square root of 300 divided by pi is about 9.77 feet. All right, I hope you see where square roots and quadratics come together and are able to do these problems. I would like you to try to do the homework. 20 through 28 evens, 41, and 54. Again, please try. Thanks for listening. Have a great day.